Hi, hello again. So in this segment, I'd like to address one issue that sometimes causes a lot of confusion, which is um, this usual conflation of statistics and mathematics. So what I'd like to argue in this segment is that we can benefit a lot from not taking one as equivalent to the other. And there are more interesting ways to think of statistics beyond its mathematical um, underpinnings. Let me share my screen. So good. There are here in two different ways. There are non-canonical, non-consensual ways of think of statistics, but I think it helps to communicate the idea I'd like to deliver in the context of this series of videos. So one more usual way to think of statistics is to treat it as almost as a branch of mathematics, right? Statistics as being just um, a way of applying mathematical formulas to achieve some numerical results. This seems to me to be an impoverished way to understand or to define what statistics can do and offer in terms of supporting data analysis in ways that can help us to understand or to learn about the world. And the second way I would suggest first to think about statistics is to treat it from more epistemological perspective, and I'm using the term epistemology here in a very broad sense. Um, Statistics indeed provide some procedures and techniques to extract information and insights and patterns from large amounts of data, more than other eventual techniques and methods could do, right? And in doing so, statistics does use procedures that are based on mathematical calculations and estimations and so on. But I think it's a big mistake to take statistics as just an equivalent or just an application of mathematical knowledge. Um, it's possible to be an informed consumer of quantitative data, of quantitative information, and even to carry some sorts of quantitative analysis without being a superstar in mathematics. I am not one, by the way, so just so you know. But I think, despite of this mathematical background in statistics, and even if we are not programming the softwares and the analysis themselves, under the hood, our computers are doing some mathematical calculations. I think it's more useful, especially from the perspective of a practitioner and a data consumer, to think of statistics as a type of epistemology broadly conceived here. If you think in terms of how epistemology is defined, epistemology is the branch of philosophy concerned with the possibilities and limitations of human knowledge. And I think this definition, it's very interesting when you put it together with what statistics does, because statistics is a field of knowledge or science, if you wish, that deals directly with uncertainties. There is no statistics without uncertainty. Okay, what statistics does and what it helps us to do is to think along the following lines. Given a set of data, what can we learn from this set of data, and with what level of precision, right? So as we can see here, statistics is not about the certainty, but what can we do assuming that our findings or results will not be absolutely precise as a mathematical formula would give us? Statistics explicitly acknowledges uncertainties in its estimations. Every time you see any statistics, and it may be as simple as a mean, this mean or this statistics, this number will be associated with a level of uncertainty. Uncertainty can be larger in some cases, smaller in other cases. It will depend on many factors as the amount of data available, on how that data was obtained, what type of data is that, what type of variable is that. But statistics will always contribute to not only to find a value for a certain problem, but how precise that value is. How much can we trust that? Should we have a more perfect knowledge than we do? How far our estimations would be from that perfect knowledge that we cannot achieve because we just don't have the infinite data necessary for that. So acknowledging uncertainty is a crucial part of this understanding of what we can extract from data, right? And again, statistics does do that every time. A point estimate, a pattern, and so on are calculated, estimated from a set of data points and observations. Okay. Different forms of data collection, including different strategies for measurement and sampling procedures, do have specific contributions to uncertainty. Different types of data collection, even using the most rigorous statistical approach to define, for instance, a sample design, there will be uncertainty involved there. And other types of sampling design may end up resulting in a larger level of uncertainty because of the different trade-offs included in how we specify, we design a sample. So if the statistics does not deliver the so propagated idea of objectivity and certainty, so why should one ever bother to learn quantitative methods? Well, as I mentioned before, statistics provides tools to process and extract info from more data than we could manually do or could we qualitative do, right? We can do a statistical calculation by hand, but the more data you get, more complicated those calculations will be and more prone will be to error. So we can basically use more modern device like statistics to handle larger and larger amounts of data. And these devices will be our friends in helping us to skip the boring part of getting those numbers out. So we can do that even if you don't know the formulas behind it. Of course, we have to know what those numbers are telling us or what is the idea behind the procedure, but we can use a lot of devices available to extract info from large amounts of data. And second, and equally important, when statistics is properly used, when quantitative methods are properly employed at the different stages of a quantitative research project, those procedures can lead to very solid, very robust results. Of course, the results will always be within the limits of the data collection, but those results will be solid and will come with acceptable, if the analysis is properly conducted, with acceptable levels of uncertainty. And what is a very interesting aspect, uncertainty in statistics and in quantitative methods They are known to a certain extent, right? We, for instance, hear a lot about margins of error, confidence intervals. All these are measures of uncertainty that help us to gauge how precise or how much can we trust that the number we achieved or result we achieved, how stable and more and less uncertain that the statistics is. If you have, for instance, just a few dozen of observations, depending on the analysis you're conducting, you may have a lot of uncertainty because you don't have enough information to achieve a higher level of precision. But if you have enough data or has collected enough information on that matter, your level of uncertainty will be smaller, and we can handle that in terms that we know more or less how precise or imprecise our findings are. And importantly, by extracting information from data, almost like a mantra that I repeated so many times here in this session, I mean much more things than just, for instance, counting or calculating frequencies and continuous in tables, which are the most common forms of dissemination of quantitative data around. Statistics provide us with very interesting and powerful tools that allow us to dive into data sets and extract very interesting insights to understand social complexities. So beyond knowing that this option was selected 30% of the time, and another option was selected X times, we can find patterns, we can find groupings in the population, clusters of, for instance, individuals who share similar traits and so on. So there is a lot we can do with statistics, even if we don't know a lot about mathematics. The important here is to understand, in my opinion, that statistics is a well-informed tool to extract knowledge from data. We can understand patterns, we acknowledge the uncertainties and the limits in that data. At the same time that we have tools to extract very important pieces of information from what can eventually look like a messy amount of columns and rows in a table. So if you are interested in statistics, but you don't, or if you are interested in using quantitative methods, you can at least be a good consumer if you don't have a much solid background in mathematics. But if you're courageous enough, I invite you to start learning some basic forms of data analysis and understand how this can contribute to our understanding of social realities and how this can inform action for social change.